Okay, hey everyone. This video is going to talk about functions and function writing. So we've been using functions now for a while in class, and we're starting to get used to the idea of sort of what functions are, how their arguments work. And today we're going to talk a little bit about that, a jump in coding that goes from coding and using functions to writing functions of our own for easier iteration and also cleaner coding, better reproducibility, etc. So as a reminder, functions are operations that we run in R. So everything from like the mean function or the ggplot function, anything that we type and open up a parentheses and then specify arguments in. And what we do when we use these functions in R, someone else has actually written them and packaged them up as a little function. And that's what makes our lives a lot easier. But so when we say use the help function to learn something about a function that's built into R, for instance, if we look at the log function, this is a summary of the function that someone has written, specifying the arguments in it, maybe some of the defaults of the arguments, the kinds of values that the arguments take, etc. And so what we're going to do today is sort of walk through what function writing looks like and talk a little bit about why it's useful and practice it in a few different ways. But so, right, we started out coding maybe week 1 or 2 of class saying R is a big calculator and we can do things like some numbers. So we could do 2 plus 3 and in our output we get 5. And that's great because we are still coding, we're using R. But sometimes when we are writing more and more complicated lines of code or multi-lines of code, we might actually want to wrap it up into a function. So we'll start with this sort of summing function, which is a pretty toy example, but it'll just start to lay out what a function looks like. And so first you have to name your function. So just as we've been naming objects and we've learned, there are all sorts of objects. We started out with vectors. We've talked about data frames. We talked about lists a little bit. A function is sort of a new kind of object in R. Specifically, it is a function, but it still kind of starts out with that same rhythm where you create a name and you use the assignment arrow. So we're going to call this function my_sum, and then you use the assignment arrow. But when you're writing a function, you always want to start with, I guess, the function as a function definition. So you write, I want to assign my sum to a function. And then inside the function parentheses, we'll usually outline what the 2 arguments of that function are. And now you can name your arguments anything you want. You'll notice there are strong conventions in R. So when you open up almost any help file, you'll see by and large, X is a pretty common argument name as like the object that you want to place inside of the function. And then there are also some naming conventions that sort of go from there, but it can be anything. So we'll play around with it a little bit. But so let's say for now, we are creating a function where we want to sum 2 numbers. And so those 2 numbers will each take their own argument. And so, we can call them anything we want. You could call them A and B. You could call them X and Y. You could call them number 1, number 2. And so I'll go ahead and do that just to make this really literal. So I'm writing a function called mySum that I want to include the arguments number 1 and number 2. And the next step is to say what happens actually inside this function is to open up these curly brackets right after the closed parentheses. So function, open parentheses, arguments separated by commas, closed parentheses, and then curly brackets. And when you go to type inside those curly brackets, convention is normally that you space down and it will sort of tab indent, which is just a readability way of saying, here's what happens inside the function. And for our sake, we're going to say inside this function, we want to create a new object called the sum. And what the sum will be is number 1 plus number 2. So what we're doing here is we are writing out the line of code that we virtually wrote before. So when we wrote 2 plus 3 in line 7, we were adding number 1 to number 2. To specify this inside a function and make it reproducible, you write out in sort of this soft coded way. So we've talked a little bit in class about like writing absolute numbers in there versus writing out values that can change based on certain values of the object. And this is what we're doing here. So number 1 plus number 2 is going to become our new object called the sum. And then we want this function to return the sum. And this looks long-winded and way clunkier than just writing 2 plus 3. And in this case, it is. Writing a function to add two numbers together is probably not optimal. But as we sort of build on all the things that can happen inside a function, as well as potentially get to iteration in our last week, these two pieces can really help you take your coding to the next level. But let's see how they work. So after the closed brackets, so I've written the whole function inside the two curly brackets. I did Control Enter, and you'll see that in the global environment, there is now a new piece in there that is not actually listed under objects or values, but there is a new subheading called my_sum, and it tells you that it's the function you wrote. And then you can try it out. So now, just like we call on other functions that other people have pre-written, we can call on the function we just wrote. So you can write my_sum, open up parentheses. And just like with pre-built-in functions, you can actually see that it prompts you with the two arguments that we specified, number 1, comma number 2. And what this means is tell me which numbers you want to add up. So let's say number 1 equals 10, comma, number 2 equals 5. And then if I run this argument, in the output, we get 15. Just as a reminder, we don't always need to specify the two arguments, because if we write them in the correct order, and in this case, in addition, order doesn't really matter, but if you write them in the correct order, then you just do my sum, parentheses, 10, comma 5, execute, and you still get 15. And this is the basic of what a function does. Now, in this case, we've soft coded number 1 and number 2 into the function itself. So there are no default values for those two numbers, but we could write it where there are default values that then we can overwrite with arguments. So we also already do this pretty somewhat often. So for instance, in the log, actually, because we have it open right now, in the log function, there is a default where the base equals the exponentiation of 1. But we could specify the base of log that we want to use. So in this case, in the help function, you can see base equals exponentiated value of 1. And here the base is a positive or complex number, defaults to e equals exponential 1. So we can set these defaults, but then still override them when we write. So what that would look like is you can write a new function, so my_sum2, and assign this with the assignment arrow, and then write function. Open up your parentheses, and let's say, yeah. So this is where we would set a default value that we could then overwrite. But so if you wrote number 1 equals 5, and then number 2 equals 10. So I just mixed those up for some reason. But so I've defaulted these already to a certain value. But then I could still write the same function here. So the sum equals number 1 plus number 2, and then return the sum. So we have the same function more or less, but we've already specified values inside the function parentheses. So that what happens when we do this is if we just write my_sum2 and run it with empty parentheses, so nothing in there, we get the value of 15 because we didn't want to change the default. So the two numbers that are in there are 10 and 5, but we could go ahead and overwrite those. So you could write my_sum2, but do number 1 equals 10, and potentially not overwrite number 2. And now our value is 20. Now, why would you want to hard code a value into this situation? Oftentimes you might be wanting to, I don't know, sometimes I like count up the top 10 words in a list of words if you're working with text data. And let's say it's nice to always have the default of top 10. So I would default n equals 10. But if I wanted to see the top 20 words, then I could overwrite it to n equals 20. But that way you don't have to type in, I always want, the top 10 words or the top 10 weights. You can sort of default to the top 10 something, but be able to overwrite it if you want. So this is a general rhythm. In the lecture for today, we also sort of talk about temperature conversion as sort of building on this idea of why functions can be helpful. So we'll go over an example of this. So for instance, let's say we want to convert Fahrenheit to Kelvin. So we can name this a function f_2_k and use the assignment arrow function. And what we're going to input is a temperature in this case. So let's say we're going to input a Fahrenheit temperature. So function parentheses temp f, or call it whatever you want the argument to be. Open up your curly brackets. So inside curly brackets, this is what we want the function to do for us. We want to create a new value called k. And the temperature conversion, for most of us who don't know, is, which I have it in front of me because I don't know, is we're going to take our Fahrenheit temperature minus 32 and then multiply by 5/9. And then we are going to add 273.15. So this is the conversion from a temperature in Fahrenheit to a temperature in Kelvin. And so we've written all that out in sort of some of it's hard coded, right? Because a conversion, those numbers don't really change in a conversion. The only thing that changes is your input, which is whatever value Fahrenheit temp F, or the temperature in Fahrenheit, is. And then we want to return the value K. So if we run this line of code again, so remember, we're not actually converting anything. We are saving this function of f_2_k into our global environment. So now we can, again, activate. So we see we have f to k in our global environment. It wants one argument, which is temperature in Fahrenheit. So let's say if it's 80 degrees in Fahrenheit, that was not a good example. Why not? Okay. I've done something wrong. Okay. I kept getting infinity or NAs, and this was not anything having to do with the function itself or the values that I was putting in. It was that I used a typo and was multiplying through by 5/0. So pros and cons is that if you were trying to copy and paste this conversion or rewrite this conversion multiple times over, then, and you make a mistake, then you would have to go back and fix that mistake also multiple times over. But one of the benefits of function writing is that once you package something up into a function, you only have to edit that function, which can be really good if I think like before I started using functions, I was often doing a lot of copying and pasting and a lot of sort of changing one or two values in something. And that can be a real pain if you make mistakes and want to go back and fix it. But all we have to do is change that 0 to a 9 in the function we wrote ourselves. And now our f to k function with a value of 32 inside the parentheses as our temp f argument should be 273.15. So that's one more example. And now we're going to do just one more to kind of show how this builds and that we can use this isn't just putting values into functions. And more often than not, I use them with multiple data frames, having multiple outputs for plotting, for converting data frames, all sorts of things. And so we're going to use our Gapminder data set that now we've used a little bit for our homework. And we're also going to be using a little bit of tidyverse. So I'll go ahead and load in the tidyverse library. And from the homework, you should also have the Gapminder library available to you. So I'm going to load in both of those things. And then, so let's say we wanted to do something with the Gapminder data. So something I thought up of was, let's say you want to calculate the average GDP per capita over a certain range of years. And as a reminder of what the Gapminder data is, it is data really about countries, what continent they're on, and then has data on life expectancy, population, and GDP per capita over a series of years, 1952 to 2007. So this is a great data set. You might want to be like summarizing a whole bunch of things. And let's say you were, for whatever reason, you wanted to know the average GDP over particular ranges of years for a given country. And this task is something that we have learned how to do with our data wrangling skills. So it might look something like, okay, I'm going to start with the Gapminder data set. I'll pipe and filter to the country I want. So let's say I'm interested in knowing the average GDP for Canada. And let's say I also want to know, so my country, so I'm filtering country equals Canada. And then I also want to say that the year range. So let's say I want to know the GDP, average GDP for Canada between 1970 and 1980. So instead of using the year equals sign, because I don't just want one yearly value, let's say I want a range. We've called upon this a few times, but not as often, to say I want years that are in, and then I can specify a certain range. So let's say I want years that are in 1950, or what did I say, 1970 through 1980. And so now we've filtered our data to the country of Canada and this range of years, and then we might want to just summarize, mean, and take our GDP per capita value. And I'm not quite sure if there are NAs in this data, so I'll just go ahead and put NA.rm equals true to be safe. And if we run this line of code, great, our output is kind of a Tibble. I strangely got an NA.rm true column, and that was because I put NA, sometimes that happens where if you put NA.rm equals true in the wrong place, it will just say, okay, I will create a column that says NA.rm equals true. That was not what I wanted. I wanted it to be calculated into the mean. So now we have this just 1-by-1 Tibble, which is more or less the value of Canada's average GDP between 1970 and 1980, and that's 20,531 of whatever units the Gapminder uses. And great, this totally works. And if you wanted to see this value, though, across many countries, across many different year categories, you might say, sure, I'll actually just copy and paste this a whole bunch of times, and I'll sub out Canada for another country, or I'll keep manipulating the years. And that absolutely works. But functions are a way of sort of making this a little cleaner, helping you iterate a lot faster through your code. And especially if we talk about iteration, how to sort of go through many points in your data using functions, then this is really where this comes to life. But we will talk about that next week. But the last thing we'll do in this video is make the jump from, okay, here is 3 lines of code that we've written out. Can we write this into a function that helps us repeat this sort of summary of average GDP across any country for any range of years that we want? So let's go ahead and say, yes, I want to write a function that does this. We can call it average GDP, use the assignment arrow, call upon our the function definition. And so I always think of the things we want to specify in the function definition are the 2 specifications that we want to be able to change or manipulate when we're exploring this data, for example. So in this instance, I want to be able to change what country I'm looking at, and I want to be able to change the year range that I'm looking at. So my 2 arguments are going to be country and year range. I am not going to spell these out completely because you may notice that in Gapminder, the column names are already country and year. And maybe Tyler and I can talk about this, but I've been taught that it's really not good practice to name your arguments the same thing that exists already as a column name. That can confuse you, it can confuse R. And so making argument names different than existing column names, I think is good practice. So in our function, we could also call these whatever we want, X and Y, but we'll call them country with an abbreviated spelling and year.range. Then we'll open up our curly brackets, and then we can really even think about, like, what does this function look like, but with soft coding to replace country and year range. So we can even start by just pasting in what we just wrote. So we're already well along our way to writing this function. Because we want to take the Gapminder data repeatedly. We want to filter out country and year and then summarize the mean of GDP per capita. But the 2 things we want to change out are switching our country and our year range from being hard-coded as Canada and 1970 to 1980 to being soft-coded as any country we put in this function and any year range we put in this function. And the way we do that is we can just delete this, the Canada character in our filter country equals function. So, and instead replace it with the argument that we will then later specify when we call upon the function average GDP. And so this is why I said spell them differently, because if you had named it country, you would have country equals country, which is a little hard to wrap our head around. But so instead, we're going to take Gapminder, pipe to filter, country double equals CNTRY, which is the name of our argument, or whatever you named it. Then comma, we're going to stick with filtering for year in, but instead of having this hard-coded 1970 to 1980, we're going to delete that and replace it with our second argument in the function, in this case, year.range. And then we keep this whole pipe to summarize mean GDP per capita NA.RM equals true, because that's a function that we want to apply to anything that we filtered in this data. And that is going to be our function. So now we have a function called average GDP. And every time now we can use these two arguments, country and year range, and iterate through these a lot quicker. This is still not as optimal as we can get, but it can make things a lot faster. So let's say I want to do, not country, that was incorrect. But my first argument is country equals, and I think this takes a little bit of getting used to of, we're still getting used to when do we put things in quotations versus when do we not. But in this case, the name of the country is going to be in quotation marks. So our first argument, country equals quotation mark, name a country. And what goes into these quotation marks has to be a country that exists in the data set. And I put it in quotation marks because you sort of imagine when we first wrote this function, or we first wrote these lines of codes outside of the function, we put Canada in quotation marks because we generally have learned that character data, when it's being called upon in a filter or almost any time, should be in quotation marks. So countries are still character data. They're not sort of these saved objects, and it's not a particular column name. So you'll still want to say country equals, and then we can pick any country that we want that exists in the Gapminder data set. But if you spelled these wrong, or you picked a country that didn't exist in this data set, the function would not work because it can't find it in the Gapminder data set. And then our second argument is our year.range equals, and then we can write, whatever date range that we want. So 1985 colon 1990, for instance. And we can run this line of code and get a similar 1-by-1 tibble, which is a bit ugly. We could rewrite this function so that it comes out as just a value, not a tibble. But for learning's sake, what we get is the GDP summary for Iran between 1985 and 1990. And so now you could, keep running this function for really any countries in our data set. Let's see, I think I did Zambia, and for any sort of year range that exists. What's also nice about this function is I think the Gapminder dataset only exists in a certain span of years, but because we're doing this year range and our function is in a particular range, you can give it a really wide range. And even if those values don't exist in the data, they'll just more or less be ignored and take everything in between. And I adjusted. So I tried to run that line of code and I got an error that it said it could not find function average GRP because there is no function average GRP. The function name is average GDP. But so this is sort of the quick exhibition of what functions can do for you, how to write them, how to kind of start building them iteratively. And so in class, we'll keep practicing this and talk about why they are useful.